Hello friends, welcome to Risingpearl.com. We are learning series 2 where we are looking at triangles. Today is webisode number 17, and friends, we will start from today and maybe over the course of next few webisodes solving questions or problems based on similar triangles. Now friends, very briefly, in the last 4 webisodes, webisode 13, 14, 15, 16, we have seen the AAA similarity rule, AA similarity rule, SSS similarity rule, and SAS similarity rule respectively. I'm going to provide those links for your quick easy reference. So starting this webisode and in the next few webisodes, we are going to look at what kind of problems you may be getting on similar triangles. So friend, the first type of problem would be very straightforward. Here all the dimensions will be given and maybe one or two are missing and you need to find out the missing one. So in this figure here we have two triangles ABC and DEF. Lots of measures or dimensions are given. That is, for triangle ABC all the sides are given and two angles are given. Similarly, in triangle DEF the measure of each of the sides are given. We need to find out the value of angle D. So when you have a question like this, friends, the first thing that you are looking to do is, because all the sides are given to you, you want to find out the ratio of corresponding sides. And then if those ratios are equal, then we can say the triangles are similar, then their angles will be equal as well. So let's quickly find out. So here let's take AC by DF. If you take these two, you have 4 by 8, which is equal to 1 by 2. 1 by 2. Now let's take a look at AB by DE. AB by DE. AB is given as 3.5 and DE is given as 7. This is again 1 by 2. Finally, let's take a look at BC by EF. BC is 5.5, 5.5, and EF is 11. So this is again 1 by 2. Cancel out, this will cancel out. This will all cancel out. So each of these ratios, each of the ratios is equal to 1 by 2. So friends, then we can say that in these two triangles we have AC by DF is equal to AB by DE is equal to BC by EF. And so therefore from here we can imply triangle ABC is similar to triangle DEF. So since now these two triangles are similar, their corresponding angles must be equal. So angle A and angle D should be equal. So if angle A is 80 degrees, then this should be 80 degrees. Similarly, in this case, if you were to find this angle, we know that sum of three angles in a triangle is 180. So if this is 80, this is 60, this should be 40 degrees. So 60 plus 40, 100, and 80, 180 degrees. So this is equal to this. So this angle is equal to 40 degrees. This angle is equal to 60 degrees. So this is one type of question where it's straightforward, dimensions are given. Most of the dimensions are given and you have to find out one or two missing dimensions. So friends, here we have similar question, find angle D. So we have to find angle D. So let's take a look at the sides. So for triangle ABC, 3 sides are given. For DEF, 3 sides are given and 2 angles are given. So we have to find angle D. Just for fun, I think let's draw this. So here, so angle B, angle C plus angle A should be 180 degrees. So 60 plus 48, so 60 plus 40, 100. So this is 180 degrees, angle A. Now let's find out the ratio for the sides, right? If you directly look at these two triangles, they don't look similar, do they? They don't just visually look similar. But let's look deeper into it. So let's see the side BC by EF. Let's look at that. BC by EF is equal to, BC is 5.5 and EF is 22. So this is 1 by 4 times, right? So the longer side is 4 times. So if you look at AC and DE, this is 4 times, right? So in other words, if you do AC by DE, then AC is 4 and DE is 16, which is equal to 1:4. Similarly, which side is left here? We looked at BC, we looked at AC, so AB is left. So AB by, which side is left in this triangle? EF, DE, so DF is left, DF. If you do this, then AB is 3.5 and DF is 14. So if you do this, friends, 3.5 2s are 7, 2s are 14, so this will cancel out. This will be again 1 by 4. So here, friends, even though visually these two triangles don't look similar, they actually are similar triangles. But it is important to know which corresponding sides are in the same ratio, and so which angles will be equal. So let's write it. So what we have here is, we have BC by EF equal to AC by DE equal to AB by DF, right? Now so because we have these ratios are equal, it implies that triangle ABC is similar to DEF. But now let's make sure that which angles are similar to which. So BC by EF. So which angle is opposite of side BC? It is angle A. So which angle is opposite of EF? It is angle D. So angle A must be equal to angle D. Now in this question we are looking to find the value of angle D, and we have found angle A is 80 degrees, so we know that this is 80 degrees. But let us just find out which of the other two angles are equal here. So now, we talked about BC and EF. What about AC and DF? So AC is this side, so the angle opposite to AC is angle B. So angle B is equal to DE. Where is DE? DE. So the angle opposite to DE side is this angle, angle F. So this is interesting, friends, to know. Normally whenever we have been having similar triangles, we have this angle equal to this angle equal to this angle, and this angle equal to this angle. Here it is not the case. Even though these two triangles are similar, but angle A is equal to angle D, angle B is actually equal to angle F, and then we will have angle C equal to angle E. So friends, this is one more question. Now before we move on to the next question, I just wanted to make sure, if for any reason, if all of these ratios are not same, even if one of the values, for example, for AB by DF, let us just say that DF instead of 14, if it is 15, then your ratio will not be 1:4, and then these two triangles will not be similar. Let's take a look at some more questions. Here the question is, are the two triangles similar? So if you look at the two triangles again, they are visually, they don't look similar. But let's look at the sides and let's look at if we can do any comparison, right? So let's see. So we have 4 and 16. So 4 times 4. If I were to write AC by DE, it will be 1:4, right? Similarly, if we were to do BC by DF, I think that will be 1:4 too. So let's write it this way. So AC, and friends, this is where it is a little bit challenging for us to see which side corresponds to which side. So AC by DE, AC by DE is equal to, AC is 4, DE is 16. So this ratio is 1/4. This is 1/4, right? So AC and DE. Next, we are looking at BC. Let's look at BC and DF. Why? Because BC is 5.5 and DF is 22, which is 5.5 times 2 is 11 times 4. This is 1/4. So we are left with AB, and here we are left with EF. So AB is 3.5, and EF is 14. So 3.5 times 2 is 7 times 4. This is again 1/4. So these two triangles are indeed similar triangles. Now, but it is tricky to find out which angles are equal to what. So the answer to the question is, are these two triangles similar? Answer is yes. They are similar triangles. But again, let's try to find out which angles are equal to which angles. So AC by DE, which is the angle corresponding to side AC in the small triangle? AC, the angle opposite to this is this angle, angle B. So we have angle B equal to DE. So in the big triangle DE, which is the angle opposite to side DE, that will be this angle, angle F. So angle B will be equal to angle F. Similarly, BC by DF. So BC, opposite to BC is angle A, equal to DF is DF, opposite to DF is angle E. Angle A will be equal to angle E. And finally, so angle C will be equal to angle F. Now angle D. So friends, one other side note which is important in this context to understand is, when we say triangle ABC is similar to triangle DEF, right? Generally when we speak like this, what we mean is angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. That is what we mean normally, right? So the right way to actually express this will be, so for example here, if you were to write triangle A, let's write it here, trying to find out if we have enough space, let's write it here. So we can say triangle ABC ABC is parallel to triangle, we don't want to write DEF. We want to write it the same angles correspondingly. So angle A is equal to angle E. So we will first write angle E. Then B is F. So FD. So friends, it's a subtle difference, but I hope that you are able to understand and appreciate the difference here. Instead of saying that triangle ABC is similar to triangle DEF, we want to make sure that we write it as triangle ABC is similar to triangle EFD, so that we match which angles are similar on both the triangles. Let's take a look at maybe one or two more examples. So here in this question, question 4, are the two triangles similar? So friends, what we have is, we don't have all of the measure, but we have AB and BC. Those sides are given, and we are given the length DE and EF. So if you look at AB and DE, it is 1:2 ratio. So let's write it down. So AB by DE is equal to 3.5 by 7, which is 1/2. Similarly, BC by EF is equal to 5.5 by 11, which is again 1/2. So I have AB by DE is same as equal to BC by EF. Now what about if I can prove that these two angles are equal, then I can say two triangles are similar by SAS similarity rule, right? So in the last three examples, this is our three questions. This is question 4. In each of the last three questions, we did not mention the similarity rule, but we were proving the similarity of the last three questions by SSS similarity rule. That is side, side, side. All the sides were in the same, all the sides had the same ratio. So in this case here, friends, we have proved that AB by DE is equal to BC by EF. Now in this triangle, if you take a look at this triangle, so A is 80 degree, this is 40 degree. We know that, let's write it here, angle A plus angle B plus angle C is 180 degrees. Sum of three angles of a triangle is 180 degrees. A is 80, B we don't know, C is 40, is 180 degrees. So from here we can find out that B is basically 60 degrees, right? Because 80 plus 40, 120, when you take it to the other side, 180 minus 120 is 60. So this is 60 degrees. Now if you look at triangle ABC and DEF, angle B is 60 and angle E is 60 as well. So here we have these sides in the same ratio, and their included angle is also equal. That is, angle B is actually equal to angle E. So then friends, we say therefore these two triangles ABC is similar to triangle DEF as per SAS similarity rule. Let's take a look at maybe one last question before we wrap up. So here friends, we have been given again two sides and an included angle. So I have got two triangles ABC and DEF. I have got two sides, the length of two sides are given, AB and BC. and the included angle is given. So here I have, so this is actually interesting. Let's take a look. So I have been given angle B equal to angle F, right? And I have been given the measure of, actually no, that is not what we have been given. So in this triangle ABC, we have been given AB, we have been given the value of AB, we have been given angle B, and we have been given the measure of BC, right? And in this triangle we have been given EF, we have been given angle F, we need the measure of DF to say whether these two triangles are similar or not. But instead of DF, we are given the measure of the length of DE. So this will be of no use for us. This information will be of no use for us. So we cannot say in this question, we cannot say if the two triangles are similar. We cannot actually say that. It doesn't look like they are similar, but we can't say because we don't have this measure. So friends, in the next video we are going to take a look at more questions on similar triangles.